The this keyword. The most misconceived feature in JavaScript is seen as basic knowledge in other programming languages. The this keyword still is a confusing topic. Even after a long day of reading books, people still get confused about its inner workings. This confusion and misconceptions is the reason for these standing four rules. Follow them religiously and you will never fall victim to this madness. Here are the rules. Default global binding rule, number one. Number two is implicit binding rule. Number three is explicit binding rule. And the last is constructor call with the keyword new. My advice, write this on a sticky note, put it beside your desk. You can also put it on your computer, but put it somewhere you're going to see it often. Now, before we start exploring, let's throw a little light on why exactly this is misconceived. When you write a piece of code, your mental model is always centered around the creation time. The creation time is the period of creating slash writing this piece of code. JavaScript has another period called execution time. This is when it's interpreting what you have written. It's at this execution time that bindings, references, and memory assignments are done. And this is expected. It's a mutual behavior in most programming language. The issue in JavaScript is that at runtime or execution, it binds value based on context. Now, this implies that a piece of logic is not necessarily interpreted in the way it is written or read by the user, but based on what is called its execution context. Let me give you an illustration of execution context. You have three security robots that patrol every night in your neighborhood. Say robot A, B, and C. From 9 p.m. to 11 p.m., robot A and B are on duty while C is charging. At 11 p.m., C is fully charged and replaces A. Now we have B and C on duty. This shift continues at an interval of 2 hours. Assuming that while at duty or execution, the pair needs to communicate each other's location and inspect areas. At the first turn, A and B were communicating. When A was substituted with C, A is not expected to continue communications with B. Rather, it should be interacting with C. Execution context changed. The environment is not the same any longer. A cannot be talking with B after a switch, but it can be talking with C. Understanding that A should not be talking to B any longer is where we get confused about this keyword. This can be seen as the current situation our robots find themselves in. Now that we know why it always gets you confused, let's see our four rules on avoiding the confusion. Now, I want you to take a close look at the following example and make a wild guess what could be logged to the console. Okay guys, let's analyze this. When not in strict mode, this refers to the global scope. When in strict mode, its bindings are undefined. So this is why we got undefined on our console. Example 1a will print SAM codes to the console because this refers to the default binding, which is global. In example 1b, this could have also referred to the global object, but because of useStrict, it defaults to undefined. Usestrict will make sure that the scope of this will be the function scope and not the global scope. Now, hopefully you understood this. If you didn't, rewind, repeat. Repetition helps with stuff like that. Repeat it and probably you will get it more the second time. Now let's talk about implicit binding. What if the function is not exposed to the global context? Now I want you guys to tell me what you think about the following example. This time, this is keeping a reference to the object that encloses its wrapping function. Therefore, the rule states, this refers to call site when enclosed in an object. Now I want you to mark my words, listen to my words, call site. The rule did not say write site, but call site. The above example will print Google, but don't expect the following example to print the same. So now let's see the example. This example prints SAM codes and not Google because the call site was not the object but the global object. Remember our security robot illustration. The execution context is what matters. What if we want print name again to refer to the company object even after the call context is not the company object but the global object? And that leads us to what? The explicit binding rule. In the explicit rule, you can explicitly manipulate the call site using call, apply, or bind. We can manually make print name again refer to the company object as its call site. Usually when we call print name again, it refers to the global object, but now we use the call method to hardbind company as its execution context. Now I know there's a question, what about the parameters? When the function has a parameter, you can just pass it in after the context. The print name function expects a prefix and a suffix parameter. When calling the passed function print name again with call, we pass the parameter after the company object binding. The last one it bind, it acts a little different from call and apply. Call and apply execute the function, and unlike them, bind doesn't. What bind does is to bind the correct context and return the function with the adjusted context. Now the last rule is constructor call with new. The last rule surfaces when you see a function with the new keyword. New keyword creates an imaginary object in a function which is linked to the prototype object. This imaginary function is returned implicitly by the function if there is no existing return statement in it. Now guys, let's break this down as simple as possible. I hope you're with me. I hope you're understanding it. If you aren't, rewind, start from the beginning and watch it again, and make sure you're taking notes. If I follow the following functions and then attempt to call that function with new, the comments below show ideally what happens internally. An imaginary object is created called this, and if that function doesn't return anything, this is returned. Therefore, you can use the function call as an object. The rule also says this object is linked to the prototype object. Prototype linking is beyond the scope of this tutorial video, but it will cause no harm if we see an example of such link. We just attached a method getName to the company's prototype object. This method has access to the same this object which was created in company. A function that will be called with the new keyword is called a constructor function and usually written in little case, while a call to the function with the new keyword is called a constructor call. Now let's talk about order of precedence, guys. It really matters here. It's essential to note that the rules are applied in order of precedence, meaning that if two or more of the rules are found in the same scenario, there is an order in which they are applied, and it is as follows. It is first constructor call rule 4, then explicit binding rule 3, and then implicit binding rule 2, and default binding rule 1. And I hope you notice that just reversing the rules shows their order of precedence. Now, I want us to quickly talk about the common pitfalls, and one of them is async handling. And if you don't really understand async handling, I'll leave a card above for my async tutorial. There are a few known pitfalls with this binding. They are most noticed in async logic that receive callbacks as handlers. These handlers are often bound to a different context, making this behavior unexpected. Event handling is one such situation. Event handlers are callback functions that are passed to the event registration. These callback functions are executed at runtime when the event is triggered. Now guys, here is a basic example. This is an intended behavior until you need to access this from an outer context. Now look at this, guys. The click event handler is a method in the company object. Event handlers, as we already mentioned, had their own this binding, but then we need to access company via this. Running the above sample will throw an error telling you name property could not be read. And worse still, the name property exists as an event, this property thereby generating weird results and not even throwing errors. Now let's fix it with this code right here. And we click on it and you can see that we get SAM codes. I will leave in the description all the code that we went through in this tutorial right here so you can check them and try them out yourself. And yeah guys, that's it. That's what this does and nothing more. Next time you meet this in a code snippet or a code sample, don't forget that it's holding contextual information about the running code and not the written. To debug this, avoid reasoning about it from the code editor. Put out your browser and add breakpoints where they are encountered. That way, you would learn exactly what a this binding is storing and where the values might be coming from. And this is it for this tutorial. Hopefully you learned from it. And right now, I'm sure that even if you might have problems with this, you have a set of rules that you can use to clarify it and make it more understandable. I'm going to wrap this up and I'll keep things moving, and I'll see you all in the next YouTube video. Please like, subscribe, comment down below if you have any questions.